Okay, so in this video we're doing some more review about triangle congruence, talking about side, angle, side, those kind of things that you probably have heard of before. So just a refresher, if you need to skip this video, go ahead, but make sure you know these rules. So in side, triangle congruence, we're told that if three sides of one triangle are congruent to three sides of the second triangle, then the two sides have to be congruent. So for instance, if we know that MN is congruent to QR, and we also know that NP is congruent to RS, and we also know that MP is congruent to QS, so three pairs of sides are congruent in these two triangles, then that automatically means that these two triangles are congruent themselves. Side angle side triangle congruence, similar to what we just did. If two sides of the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So based on the picture, what we're saying is we're looking for side congruent to side. So PQ congruent to WX. Then the included angle. Included means the angle is in between our two sides that we're using. It has to be between for this to work. So side, angle. So the angle Q is congruent to angle X. Side. Side QS is congruent to side XY. Again, side, angle, side, side, angle, side. If we know those three things, then that's enough to say that these two triangles are completely congruent, completely the same size, same shape. All right, in example 7, we're told to use SSS congruence to show that these two triangles are congruent. So first off, we're on the coordinate plane. And let's go ahead and figure out what the easy sides are. When I say easy, since it's going straight up and down, straight left and right, I can just count. So this side right here is 1, 2, 3, 4, 5 units long. So we have 5 units long here. This side is 1, 2, 3 units long. Well, obviously based on the shape, it's a right triangle. So what I can do now is to use Pythagorean theorem to find my third side. So what I'm going to say, this is obviously my hypotenuse, so that's C. So I'm going to say A squared plus B squared equals C squared, and I'm going to plug in what I know. So C is what I'm trying to find, and it doesn't matter which one I call A or B, so I'm just going to say 3 squared plus 5 squared equals C squared, and now we just clean it up. So I have 9 plus 25 plus C squared, and 9 plus 25 is 34. That's C squared. But I don't want C squared, I want C, so we have to take the square root on each side. So the square root of 34 equals C. I'm going to leave that alone. You could turn that into a decimal if you want. I'm going to leave it alone. All right, let's go on to the other triangle. Again, I'm going to find the easy sides first after just counting. So this side is 1, 2, 3, 4, 5 units long. This side is 1, 2, 3 units long. All right, so far so good. Now it's a right triangle, and this side is my hypotenuse C. So that means A and B are exactly the same. So we have A squared plus B squared equals C squared. 3 squared plus 5 squared equals C squared. And it's the exact same problem that we just did, so we know that when we go through all of this, since we've already done it, C is going to be the square root of 34. So since I have a side congruent to a side congruent to a side, and a side congruent to a side, that means that ABC is congruent to triangle FGH. It's really that easy. So a couple more rules. The angle side angle theorem. So here we have to have two angles and the included side of one triangle are congruent to two angles and the included side of the second triangle. Then that's enough information to say that the two triangles themselves are congruent. They're the same size, same shape. So here in the picture, we have angle, side, angle. So A matches up with angle D. Side AC is included because it's in between my two angles that I'm talking about, and it's congruent to side DF. And then finally, angle C is congruent to angle F. So we have angle, side, angle, angle, side, angle. That alone is enough to say that the two triangles themselves are the same size, same shape. They're congruent. And then finally, angle side is another rule that tells us the triangles are congruent. If we have two angles and the non-included side of the triangle are congruent, the two angles and the corresponding non-included side of the second triangle, then the two triangles themselves are congruent. So here in the picture I have two angles that are congruent, and the non-included side is congruent. That's enough information to tell me that triangle ABC is the same size and same shape as triangle DEF. And that's it for triangle congruence. These rules that we just went over should have been reviewed for you, so make sure that you do know them really good.